Okay, so we're faced again by this problem. Ways of expressing. Okay, it's pretty tough. I don't have an idea. I'm a little pressured, so that's why. If we could think about ways of expressing different coins, that would be the best, really. Okay, let's think about it this way. If we have 1, we can express it one way. If we have 2, we can express it in 2 ways. So what happens here is you see if there is, you take all the numbers that are listed in a certain number, and you try them all, right? So you try 1. If it goes down to 0, you're good. If you try out all the different values again, 2, 2, 2, 2, 2, 1, you're trying the max value that can subtract it, and then you're using lesser numbers, right? That's a good way. Okay. That's an interesting start. Okay, so for example, 10. It can be 10. Now it can be 5, 5. Now it can be 2, 2, 2, 2, 2, 2, 1, right? Okay, but that's just different ways. But it's not all the ways of expressing it.
I've had 3 wrong answers already. Yeah.
Let's see, 10, 5, 2, 1.
Like I'm doing something with Fibonacci, so I just want to make sure that it's correct. I don't think plus. So yeah, let's start to meet right now. I'm gonna try to print the first one on Fibonacci. Just take count. And then with an online source, if they get the same Fibonacci, if it's not the same Fibonacci number.
So I'm back. I found a mistake in the tens and it freaked me out.
Let's see, every 2 you can express twice.
Ones are fine.
Right, and then so
20.
it's getting weird. Okay, 5. How many different ways do you have of expressing 5? Just 4 times, right? Just 4 ways. No, 20. 20 can be 10.
36. 40.
Let's think about different ways of expressing a number using smaller numbers. You can just try them. Well, yeah, it's the solution for those who don't understand. We have to really think about this. Let's see, 10 can be 5, 2, 2, 1, right?
18. I'm really confused as to why this isn't working properly.
So we're asking 2.
Take a look what happens if I put a 2.
So for all the different ways of expressing it, 4 makes sense for 5. Okay, so then we can express 10, 5 times 5 plus 1, right? And then if this is 2, then it's just 2 times 2. Just add 2 small numbers by themselves, and then plus 1, right? 1, 2, 3, 4, 5, and then we get 20 as well. So we can express 20. So that's 2. Yeah. So that's okay. Here's 3. 2. Right. So okay, for example, 5. In this case, 5 can be expressed as 2 2s, right? Ouch. Okay, 2 2s. Well, we thought about all the different ways of expressing 5, right? And different ways of expressing 10 are the same as all the different ways of expressing 5, the items themselves. Plus, we have 10. Plus, we can do all ones. Oh wait, but that's one of the ways, isn't it? Yeah, it is one of the ways. So if it's okay, so we shouldn't add. Okay, and here we should add 1, 2, and let's think about it again. 17 times 17. Yeah, that's good. Plus 1. Okay, that's 1, 2, 5, 10, 20. Okay, so this is different ways of expressing 20. 50. I mean, 50 can be 50 is just 20 plus 20 plus 1 plus 10, right? 20 plus 20 plus 1. Right.
I just changed count to C and then I C,
20 plus 20 plus 1 plus 10. Sorry. 20 plus 20
It
plus
seems
10.
that all my smaller methods. Okay, I'm doing the one with 1,000 in words.
Okay, 20 plus
Okay,
20
I've tried
plus
this out
10.
before.
That's different ways of expressing. So,
It seems like I've done all the methods right. How to get numbers between 1 and 10. How to get between 1 and 20. How to get between, between 10 and 99. Between 100 and 999.
okay, so this is just times 2, right?
They all seem to
And
work
then-
fine.
What's the final thing? The size of the string or something?
No, how many total numbers?
So I'm going to time that
Go through and add them.
by the number of 10s we got, which is 17. It's getting really weird here.
And I've checked all of them.
Okay, now different number of ways of getting 100. That's
Not
just
seeming to get it.
50 times 50, you know? Okay, you know, let's compute this. And just
Like,
more
give me
from
an
alpha, you know?
value between 1
Let's
and
see
1,000
where
and
we're
it'll
going
work.
from here.
But then when I try to add them all
We
up,
might not even have to do all this programming we did.
900.
Not the smartest way.
Okay.
Okay,
I don't know.
let's see. Let's see what this gives us.
Can you put something in just to sort of
Okay.
tick it over, so print something out as it's thinking?
What do you mean?
Just to check.
Now
it's
let's
not
see,
just-
100. What does
Does it finish?
it give us?
Yeah.
Oh, you sure it finished?
100. What does 100 give us?
It is giving me a value, it's just wrong.
Okay.
And all my
So what value is
methods,
it giving?
21,000 and something. I don't know.
Does that make sense?
Yeah.
It's not like an off by one thing or something.
It might be.
Okay. So think about what off might one be in this circumstance.
Okay, wait, before we compute this.
I've included the final digit, the 1,000. It didn't make sense to make another method.
This is 1, 2, 5, 10, 20. Did 20. And then 50. Okay, we gotta add 1 to this because
100 and is 10
we
letters.
forgot.
Yeah.
We gotta add 1 to this.
But that feels like what it could be. You know what I mean?
I'm really, I think that's what it is. I'm struggling.
Okay, so I just added 1 and I square rooted that. Sorry, square that. Let's try this whole different solution and square that. Oops, how many squares do we have? 1, 2, 3. 2, 3, 4.
It seems
1,
that every value is working
4.
except for when I add it all up. I get the wrong thing.
Okay, so we add 1 again and we square it.
This is so stupid. Is it legal to go to Wolfram
Wow,
Alpha?
we're getting into
Yeah,
really
check
big
the
numbers
answer.
here.
Yeah, it's a little-
I doubt it's
You're not looking
that many
up-
ways.
Well, I don't want you to check up, what is the answer to the project or whatever it is.
No, not the method, like final answer. So I don't keep submitting it. I'm gonna go to Wolfram Alpha and not check 1 to 1,000, but 1 to 100. And
Yeah,
just see,
it's another tool,
see if,
Let's think about the
Oh,
different
and
ones.
I don't know how
1,
to use
okay,
it.
2 is 2 and 2 ones, right? So that's 2 ways. 4
Which
is
problem you working on?
2 1 1,
17.
2 2, 2 1 1. Oh, 5 games. 2 1 1.
21 4
What, tell me what
Oh,
you
just
got?
2 times 2, right?
2 1 4 2 2.
2 times 2.
It's ballpark. It's ballpark.
So you subtract
You're out
1.
by something like 300.
Really?
That's around
Yo, Stay, can you tell me, Stay, can you tell me the approximate magnitude of 31?
31.
Yeah, because I'm getting to really giant numbers. Okay, I'm just asking my teacher.
How do you? It has an order of magnitude of tens of thousands. Yeah.
Tens of thousands. Okay, thanks. Okay, tens of thousands. Okay. Let's see, 5. That'd be 2 2 1. Right. 2 1 1 1. Two, 2 1.
Just trying to do some debugging at this point.
2 1
I'm sure
1.
it's kind of minor
So it's just 2
error.
times 2
Yeah.
plus 1, right?
You're in that range.
So-
It may be, by the way, something
2
to
1, 2 1 1 1, all ones, and a 5. So it's 3 plus 1, right? Okay. Now for number 10, what is the solution for 10? It's basically, yeah, so it's 4 times 4, that's right. Plus 1 for the 10. Good. 17 times 17.
Uh-oh, come back.
Okay, so this is for 10, and it's not correct.
What just happened?
Let's think about it this way.
What's going on?
I got 10 on one side, I got 10 on the other. How many ways can I use to express? 10, 10. Can break it into 5, 5. Okay, so it's definitely multiplication. Just don't see why it's not giving me the right answer. 10
101.
for 24. Sorry, for 20. Should be just 10.
101 is wrong.
10 times 10. 17 times 17. So,
100.
okay, Wolfram Alpha says 290. Okay, that looks like it's in the right range. Okay, but then here we're getting into a little trouble, because 50 can be expressed as 20, 20, and 10. Right, so I'll make it 20, 20, and 10.
19. There's no way it should be 19. It should be 16.
20, 20, and 10.
Alright, that gives me a clear reason for what's going on here. It's in the tens of, if I can tens of 1. That's the problem.
20 and 20 and 1.
Aha. I found a solution. 6 can't be 6. So.
Okay, I'm adding a 1 to it. I think this is already a pretty big number.
If n is
Yeah,
less than
it's a
10,
very big number. Should be.
return units n.
Just make sure.
Oh, that should do it. Let's see what goes
Oops,
on
when
now.
I did closing this. 1 million. Shit. And, sorry to say, in the tens of thousands? Just tens of thousands?
It's yeah.
Oh, okay. I'm getting really.
More than
Mr. Daly, I was too big, right?
more than 9,999.
My number was too big.
Yes.
So
100,000.
my number was too big, right? Not
Okay,
too small.
so my number is way too big.
400s, right?
Let's think about this again.
Too big. Great.
So let's think about this stage again. Okay, 10. So we have 10. How many different ways of expressing it do I have? I have 5, 5, right? Then all sorts of different ways expressing 5 on one side. If I use all these, oh, that's.
Feels like a little
I get it.
Go in here.
Okay. 441. Different ways of expressing 5. Different ways of expressing 5 here. Okay, so I'm just taking the permutations and I'm not dividing. So I have to divide.
Oh
You
my
have to
gosh.
start dividing.
Mr. Daly, I think I'm even closer. Can you tell me how much closer I am now?
I can't remember what that is.
Okay, let's see. See again. Different ways. Okay, I need a pencil here, so I'm stopping the recording. I'll be back in a sec.